Hi, welcome to 8.2. We're talking about solving systems of equation by elimination. So to solve a system of equations using elimination, so we have some rules outlined for you here. So basically what you have is you have both of them in standard form. If you remember what standard form was, it was ax plus by equals c. So the important thing about elimination is that you either recognize that it is in standard form where your x's are lined up, your y's are lined up, your equal signs are lined up, and your constants are lined up, or you might have to adjust it so it's like that. But it's important that both of those are in standard form. So what we have to do this is we need one of the terms must have opposite coefficients. And remember, coefficients are the numbers in front of the x and the y. So we need one of those variables, whether it's the x's or the y's, to have opposite coefficients. Now, sometimes we might have to force that by multiplying one equation or both equations in some situations. Now, what we're going to end up doing then is we're going to add the equations together. So once we get to that point, what we'll do is we'll add down vertically, and we'll show you in just a second here. Then what we're going to do is, what that's going to do is eliminate one of the variables. Once we have that, we can solve for the variable. Then we're going to go back and plug it in, and then we're going to check the solution. So what we want to do is, number one, we want one of the terms must have opposite coefficients. So if I'm looking at a situation like this, first step, check, are my x's lined up? Yep. Are my y's lined up? Yep. Are my equal signs lined up? Yep. Are my constants lined up? Yep. So this one is ready to go. Now, we need opposite coefficients. So take a look here. We have 2x and 6x. We have a 5y and a negative 5y. So we're not going to look at x's this time. We're going to look at y's because we have 5y's and I also have a negative 5y. Okay, so what we're going to do now, so this is the first step, and it just so happens that this one is done for us already. So what we're going to do is we're going to add down the line. So I'm going to say 2x plus 6x is going to be 8x. Now, add down this line. I've got 5y and I've got negative 5y. So that's going to end up being 0y. And then I have equals, I have 17 minus 9 is going to end up being 8. Now, you might look at this and say, well, 0y is just going to end up being 0. And that's true. So really what we have when we add down the line is we have 8x equals 8. So that's going to be the first one. We're going to add the equations together to eliminate one of the variables. Notice now down here, we only have an x in the situation. Then what we're going to do is we're going to solve for the remaining variable. So I have 8x. We know that we're going to divide that by 8, and I get x equals 1. So now that I know that x equals 1, we're going to look at step 4 here, and we are going to substitute the value from step 3 into one of the original equations to solve for the remaining variable. So basically at this point, we're going to go back up and we're going to look at our original equations. And I know that x equals 1. So what I want to do is I want to find out which one of these would probably be easiest. Since I'm plugging a number in for x, let's just go with the smaller number up here. Let's use the top equation. So what I'm going to do is I'm going to plug in 1 in place of the x. So I now have 2 times 1 plus 5y equals 17. So 2 times 1 we know is 2 plus 5y equals 17. So what we can do at this point now is we can subtract the 2, and we're just solving a two-step equation. So I'm going to divide by 5, and I've got y equals 3. So now I know my x equals 1 and my y equals 3. So the coordinates, if these were graphed on a coordinate plane, like we did when we were solving by graphing, these would cross at the point 1, 3. Remember, a solution to a system of equations is the point where they both make, or both equations are true. So let's just go ahead and try this real quick. I'm going to plug in 1 for x and 3 for y. So 1 for x and 3 for y. So the top one is going to be 2 times 1 plus 5 times 3 equals 17. And that should be a true statement. So this is going to end up being 2 plus this is going to end up being 15, and that equals 17. So that checks out. Let's do it for the bottom one now. So I'm going to plug 1 in for x. So it's going to be 6 times 1 minus 5 times 3 equals negative 9. So this is going to end up being 6 minus 15, and that does in fact equal negative 9. So this checks out. So notice, the solution is the point where if you plug them into both equations, it makes two true statements. So this one was set up for us. X's were lined up, the Y's were lined up, the equal signs, and the constants. They were all lined up. They were in standard form. And in this situation, we had opposite coefficients. That's not always going to be the case. Because if you look at something like this, we might need to multiply one of the equations. So if you look at this and you see that you have A's lined up, S's lined up, equal signs, and constants all lined up. Now, that works. We know we're set up. But remember, we need opposite coefficients. I have a positive 1 here, and I have a 2.5 here. I have a 1 here and a 1 here. So now if you're thinking, okay, I have a 1 and a 1. These are the same coefficients. Now, the trick to this is we want to set them up so they're opposite coefficients. Well, what I can do is I can multiply both sides of the equation by the same number. And in this case, since I have a positive 1, I'm going to multiply it by negative 1 up there. And what you're going to see when you multiply the top by a negative 1, you multiply a negative 1 times A is negative A. Negative 1 times S is negative 1S. I'll just put the 1 there just for now. I've got negative 1 times that is negative 101. Now, I didn't touch the bottom equation, so this is going to remain the same. So 2.5A plus 1S. And be careful if you're writing S's. I typically stay away from S's because they kind of look like 5s. If you write them fast, you could see how that would look like a 15 almost instead of a 1S. But for now, we recognize that we have a negative 1S and a positive 1S. So this is that first step where we said, okay, we need opposite coefficients. Now, we're going to add down the line. I've got negative 1A, and I am adding 2.5A. So this is going to be a positive 1.5A. I have a negative S and a positive S, so I'm going to add those up, and that's going to be 0. I've got a negative 101 plus 164 is going to end up being 63. So now I've got 1.5A equals 63. What I can do is I can divide by 1.5, and I get A equals 1.5. Let's pull up the calculator. Whoops. Oh, come on. There we go. Pull up the calculator. I've got 63 divided by 1.5, and that's going to end up being 42. So I know that my A is 42. Now, what I want to do is I want to go back and plug this into one of the original formulas. Always look to see which one is going to be easiest. And in this case, I'm going to say it's going to be the top. So I have 42 plus some S is going to be 101. And what you can do is solve for that S, 42. And you've got 101 minus 42 is going to equal 59. So I know that S equals 59. Now, normally I'd like you to write these in coordinate points like this, but when it's something other than X and Y, you can just write them out as A equals 42 and S equals 49, or 59, sorry, 59. Now, what should end up happening if you plugged it into the bottom equation? Let's just go ahead and use our calculator here. 2.5, so 2.5 times my A value, which is 42, plus 1 times my S value, which is 59. When I hit enter, this should spit out a 164, and it does. So we can see that this entered those numbers into the equation, and it comes up with a true statement. So we look at another situation like this, and we say, okay, my X's are lined up, my Y's are lined up, my equal signs are lined up, and my constants are lined up. Great. Now, what we want to do is we want to find out which one of those variables that we want to get rid of. Now, does negative 2 go into 7? No, not nicely. But does 5 go into 15 or negative 5 go into 15? Yes, it does. So it's going to work out nicely here. I'm not going to multiply the top one this time. I'm going to multiply the bottom one because we want these coefficients to be opposite. And you want to pick the one that's going to be easiest to get to. So we're going to multiply this bottom equation, everything, both sides by 3, because that will give us a negative 15 to match up with our positive 15. So I didn't touch the top one, so let's just copy it down. 15y equals negative 32. I multiplied the bottom one. I got 21x minus 15y equals 51. Now, we're going to go here, and it's going to be 19x. I've got 15y and negative 15y. Those are 0. I've got negative 32 and 51, which is 19. I'm going to go ahead and divide this by 19, and I got x equals 1. Now, we need to find out what y is, so let's go back up to one of the original equations. We are plugging in for x. So which one of these is going to be easiest to plug in? Well, it doesn't look like it makes a big difference, but let's just go ahead and put it in the bottom one. So I'm going to plug in 1 for x in the bottom one. So I have 7 times 1 minus 5y equals 17. So now I can go ahead and say 7 minus 5y equals 17. Subtract the 7 from both sides, and I get negative 5y equals 10. Divide by negative 5. Divide by negative 5, and I get y equals negative 2. So now I know that my coordinate point is going to be 1, negative 2. And if you took that and you plug it into the original equations, you would see that it works out. If you plug in negative 2 times 1 plus 15 times, plus 15 times negative 2, this should come out as negative 32. And then 7 times 1 minus 5 times negative 2 should come out to be 17 as well, and it checks out in both situations. So that's solving, multiplying just one equation, or really already having them set up for you like this right here.